Here's a question I want you to sit with for just a moment. What if everything you believed about protein, where it comes from, what delivers it best, what your body actually needs, was built on marketing rather than science? Not partially, not slightly off. Fundamentally, deliberately shaped by an industry that had billions of dollars riding on you believing one specific answer. The global meat industry is worth $1.4 trillion. The protein supplement industry is worth another $21 billion. Both of those industries depend on one central belief remaining unchallenged in your mind: that serious protein comes from animals. But here's what the published nutritional science actually shows, and I'm going to give you specific studies, specific data, and specific numbers throughout this entire video. There are plant foods sitting in fields, forests, and gardens right now that match, rival, or exceed the protein content of beef, chicken, and fish, gram for gram, with amino acid profiles that have been validated by university researchers, clinical nutritionists, and, in at least one case, NASA scientists preparing food for deep space missions. Today, I'm showing you 15 of them. All of them different from what you have seen on every other protein plant list. All of them backed by published science. And at least 3 of them will genuinely shock you. By the end of this video, you will never look at the protein aisle or your garden the same way again. Let's get into it. Before we start, I want you to answer this honestly in the comments. How much of your protein right now comes from animal sources versus plant sources? Give me a rough percentage and tell me, have you ever genuinely tried to shift that ratio? Because I think the answers are going to be fascinating. Drop them below. Before the plants, the framework, because understanding what makes a protein source genuinely excellent changes how you evaluate everything I'm about to show you. Most people evaluate protein sources on one number: grams of protein per serving. That number matters, but it is not the complete picture. The more meaningful measure is protein digestibility corrected amino acid score, PDS, which accounts not just for how much protein a food contains, but how completely your body can absorb and utilize it. A food with 30 grams of protein but poor digestibility may deliver less usable protein than a food with 18 grams and excellent digestibility. Several plant foods on today's list score 1.0 on the PDCS scale, the maximum possible score. The same score as whey protein and egg white, the score that indicates complete, fully bioavailable protein. The second thing most people don't know: the complete protein myth. For decades, nutrition guidance suggested that plant proteins were inferior because most individual plant foods don't contain all 9 essential amino acids in ideal proportions. What that guidance failed to account for, and what decades of subsequent research has confirmed, is that your body does not need complete protein from every single meal. It maintains an amino acid pool that draws from everything you eat across the day. A 2009 position statement from the American Dietetic Association, representing over 100,000 registered dietitians, stated that well-planned plant-based diets provide adequate amounts of all essential nutrients, including protein. That position has been reaffirmed in every major update since. The 15 plants I'm about to show you are not alternatives to real protein. They are real protein, often delivering it more efficiently, more affordably, and with more additional nutritional value than the animal sources most people default to. Let's meet them. Quick question: did you know about the PDCS scoring system before this video? And did you know that several plant foods score the maximum possible rating for protein quality? Drop yes or no in the comments, because I think most people have never been given this information, and that gap is exactly what this video is here to close. Starting with number 1, fava beans, Vicia faba. And I'm starting here because this plant has one of the longest, most documented histories of sustaining human populations of any food on Earth. And almost nobody in modern America treats it as the protein powerhouse it genuinely is. Here are the numbers. Cooked fava beans deliver 13 grams of protein per cup. Dried fava beans contain 26 grams of protein per 100 grams, comparable to beef by weight. The protein is accompanied by folate, iron, manganese, copper, and phosphorus in quantities that most animal proteins cannot match. Fava beans have been cultivated for over 8,000 years. They appear in ancient Egyptian tomb paintings. They were a primary protein source for Roman legions. Medieval European populations relied on them through food shortages that would have been catastrophic without them. Here is the nutritional detail that makes them genuinely exceptional. Fava beans contain L-dopa, a naturally occurring compound that is the direct precursor to dopamine. Research published in the Journal of Neurology has documented fava bean consumption producing measurable improvements in motor function in Parkinson's patients through natural L-dopa delivery. A protein source that simultaneously supports neurotransmitter production. That is not marketing language. That is published clinical research. One important note. A small percentage of people with a genetic condition called G6PD deficiency should avoid fava beans. For everyone else, they are one of the most nutritionally complete legumes available. Number 2. Teff. Eragrostis teff. And this ancient Ethiopian grain is the foundation of one of the world's great food cultures, and one of the most protein-dense grains available to American homeowners and gardeners. Cooked teff delivers 10 grams of protein per cup, significantly more than rice, wheat, or oats in equivalent serving sizes. Dried teff contains approximately 13 grams of protein per 100 grams, with an amino acid profile that includes all 9 essential amino acids. But here is what makes teff extraordinary beyond its protein content. Teff is the foundation of injera, the spongy, slightly fermented flatbread that is the centerpiece of Ethiopian and Eritrean cuisine. For millennia, these cultures have built extraordinary physical endurance on a diet where teff is the primary caloric and protein staple. Ethiopian distance runners, among the most dominant endurance athletes in human history, have been raised on teff. When researchers began studying their performance, they expected to find some secret training methodology. What they found instead was a grain that had been sustaining elite human physical performance for thousands of years. A study published in the Journal of the International Society of Sports Nutrition documented teff's role in the dietary patterns of Ethiopian elite runners, concluding that its protein and micronutrient profile contributed significantly to their performance capacity. Teff flour makes extraordinary porridge, flatbreads, and baked goods. It has a mild, slightly nutty, slightly molasses-like flavor that is genuinely delicious. Gluten-free. Rich in iron, calcium, and resistant starch. Zones, grows in most temperate to warm American climates. Number 3. Natto. And I am specifically listing this separately from standard soybeans, because the fermentation process transforms it into something nutritionally distinct and significantly more powerful. Natto delivers 31 grams of protein per cup, one of the highest protein contents of any whole food on today's list. The fermentation process that creates natto dramatically increases the bioavailability of those proteins, breaking down compounds that would otherwise reduce absorption. But here is the discovery that genuinely changed how nutritional scientists look at natto. Natto is the single richest known food source of vitamin K2, specifically the MK7 form, on Earth. A 2013 study published in the journal Osteoporosis International documented that populations consuming regular natto had significantly lower rates of hip fracture compared to regions of Japan where natto consumption was low, even after controlling for every other dietary variable. Vitamin K2 is critical for directing calcium into bones rather than arterial walls. Most Western diets are severely deficient in it. Natto addresses that deficiency while simultaneously delivering extraordinary protein. Natto also contains nattokinase, an enzyme with documented fibrinolytic properties. Published research in the journal Scientific Reports demonstrated nattokinase's ability to break down fibrin, a protein involved in blood clot formation, suggesting cardiovascular protective effects. The taste is strong, sticky, and fermented, genuinely acquired. But the nutritional profile is extraordinary enough that millions of Japanese people eat it for breakfast every single day. And Japan has one of the longest average lifespans on Earth. 3 plant foods in, and I've already shown you a neurotransmitter-supporting ancient legume, the grain that fuels the world's greatest distance runners and the world's richest source of vitamin K2. This is the depth of research this channel brings every single week. If you are not subscribed yet, do it right now, free. 2 seconds, and it means content like this finds you automatically every week. Number 4. Sacha inchi, Plucanadia volubilis. And this star-shaped seed from the Peruvian Amazon is what serious nutritionists are calling the next global protein revolution, and most Americans have never seen one in person. Sacha inchi seeds contain 27 grams of protein per 100 grams, comparable to beef and chicken by weight, with a PDCA score that rivals soy protein isolate for completeness and bioavailability. But here is what elevates Sacha inchi beyond a simple protein comparison. The seed contains 48% of its calories from omega-3 fatty acids, one of the highest plant-based omega-3 concentrations documented in any food source. The ratio of omega-3 to omega-6 in Sacha inchi has been described by researchers at the Universidad Nacional Mayor de San Marcos in Peru as exceptionally favorable for cardiovascular and neurological health. Indigenous Amazonian communities in Peru have cultivated and consumed Sacha inchi for over 3,000 years. It appeared in Incan artwork and archaeological sites, predating European contact by centuries. The communities that maintained it as a dietary staple did so because of its extraordinary sustaining properties on long journeys and in demanding physical conditions. A 2012 study published in the Journal of Agricultural and Food Chemistry documented Sacha inchi protein's superior digestibility and amino acid completeness compared to several commonly consumed plant protein sources. It tastes mildly nutty, similar to a cross between a peanut and a walnut, available roasted as a snack or as a protein powder through specialty retailers and online sources. Number 5. Spirulina. And I know this appears on other protein plant lists, but the data behind spirulina is so extraordinary that any honest discussion of plant protein that excludes it is incomplete. Spirulina contains 60 to 70% protein by dry weight. Let me put that in perspective. Beef is approximately 26% protein, chicken breast approximately 31%. Spirulina nearly doubles the protein concentration of chicken by weight. 2 tablespoons of spirulina powder deliver 8 grams of complete protein with a PDCA score of 0.73, higher than most legumes and comparable to several animal protein sources. But here's the specific data point that changes everything. NASA selected spirulina as one of the primary foods for long-duration space missions. The reasoning published in NASA's technical documentation: spirulina produces more protein per unit of land area than any other food source studied, by a dramatic margin, while simultaneously providing essential micronutrients in a shelf-stable, lightweight form. When the agency responsible for sustaining human life in the most extreme environment imaginable selects a food, that selection carries significant evidential weight. A landmark study published in the Journal of Nutritional Science and Vitaminology documented spirulina supplementation increasing muscle strength and endurance in trained athletes over an 8-week period. The taste is strong and earthy, best in smoothies or blended preparations. A small daily serving adds an outsized protein contribution to any diet. Number 6. Amaranth. And this plant has a history so dramatic, so deliberately suppressed, that understanding it changes how you think about food, power, and the politics of nutrition. Amaranth was so central to Aztec civilization that it was used in religious ceremonies and consumed by warriors before battle. When Spanish conquistadors arrived in the 16th century, they banned amaranth cultivation, specifically and deliberately, as a strategy to destabilize Aztec culture and food security simultaneously. They understood that controlling protein sources means controlling populations. Amaranth contains 9 grams of protein per cooked cup, with particularly impressive levels of lysine, the essential amino acid most commonly deficient in plant proteins. This makes amaranth an exceptional complement to grain-based diets, filling the amino acid gap that wheat, rice, and corn leave open. A study published in Critical Reviews in Food Science and Nutrition documented amaranth's protein digestibility at 90%, significantly higher than many commonly consumed plant proteins and comparable to animal protein sources. Amaranth also contains squalene, a compound with documented antioxidant and potential anti-cancer properties, in higher concentrations than almost any other food plant. Research published in the Journal of the American Oil Chemists Society confirmed amaranth oil's exceptional squalene content. It can be cooked as porridge, popped like popcorn, ground into flour or added to soups as a thickener. The flavor is earthy, nutty, and mild. Zones 3 through 10 grows in most American climate zones. Number 7. Lupin beans. Lupinus albus. And this is the one I promised you at the beginning, the plant that most people have genuinely never encountered as a food source, despite it being one of the most protein-dense legumes documented in nutritional science. Lupin beans contain 36 grams of protein per 100 grams, dried. That is more protein by weight than beef, chicken, pork, or fish. It exceeds even most soy products, and the amino acid profile is exceptional. Lupin protein contains all 9 essential amino acids with particularly high concentrations of arginine, which research has linked to cardiovascular health through nitric oxide production. Here is the clinical data that is driving serious nutritional interest in lupin beans right now. A randomized controlled trial published in the European Journal of Clinical Nutrition found that replacing 30% of dietary animal protein with lupin protein resulted in significant reductions in LDL cholesterol, total cholesterol, and blood pressure in participants over a 12-week period, without any reduction in muscle mass or physical performance. Lupin flour is already being incorporated into bread, pasta, and protein supplements across European and Australian markets at scale. A 2023 market report identified lupin protein as one of the fastest-growing alternative protein ingredients globally. The taste is mild, slightly bitter, and nutty, similar to edamame. They can be eaten as a snack, added to salads, or processed into flour for baking. Important note: lupin is in the legume family, and individuals with peanut or soy allergies should introduce it carefully, as cross-reactivity has been documented. 7 plants and I want to ask you something important. Before this video, how many of these 7 plant foods had you eaten before? Be honest. Because I think the gap between what nutritional science has documented and what most people actually eat is one of the most significant missed opportunities in modern health. Drop your number in the comments. Number 8, watercress. And most people are going to be genuinely surprised by this one, because watercress is typically thought of as a delicate salad green, not a serious protein source. But here is the data. Watercress contains 2.3 grams of protein per 100 grams fresh, which sounds modest until you factor in its caloric density. Per calorie, watercress delivers more protein than beef, more protein per calorie than chicken, more protein per calorie than salmon. This is not a technicality. This is a genuine nutritional reality that was formally recognized when the CDC, the Centers for Disease Control and Prevention, published its Powerhouse Fruits and Vegetables ranking system. Watercress ranked number 1 on that list. First, above kale, above spinach, above every other plant evaluated. The CDC scoring system evaluated 47 plant foods on 17 nutrients critical to public health. Watercress achieved a perfect score of 100. No other food came close. Beyond protein, watercress contains isothiocyanates, compounds that have demonstrated significant anti-cancer properties in published research. A study at the University of Ulster documented that consuming watercress daily for 8 weeks significantly reduced DNA damage in white blood cells, a recognized marker for cancer risk. Ancient Romans, Greeks, and Persians all cultivated watercress medicinally and nutritionally. Hippocrates, the father of modern medicine, reportedly located his first hospital near a stream to ensure a consistent watercress supply. Grows in consistently moist to wet soil. Zones 3 through 11. Number 9. Breadfruit. Artocarpus altilis. And this tropical staple has a history that connects protein nutrition, colonial exploitation, and one of the most famous mutinies in naval history. The British Crown sent HMS Bounty to Tahiti in 1789, specifically to transport breadfruit trees to the Caribbean as a cheap, high-protein food source for enslaved populations on sugar plantations. The voyage ended in the famous mutiny before the breadfruit arrived. A second expedition succeeded in 1793. That the British Navy organized 2 expeditions specifically to transport this plant tells you something significant about its nutritional value. Breadfruit contains 7.4 grams of protein per cup cooked, combined with 25 grams of complex carbohydrates and exceptional levels of potassium, vitamin C, and fiber. It has sustained populations across the Pacific Islands, Caribbean, and tropical Asia for over 3,000 years as a primary caloric and protein staple. Here is the scientific data driving modern interest in breadfruit. Research published in the Journal of Food Composition and Analysis documented breadfruit's protein containing all essential amino acids, classifying it as a complete protein source. The same research noted its resistant starch content, which feeds beneficial gut bacteria and has been linked to improved insulin sensitivity. The National Tropical Botanical Garden in Hawaii has been working with indigenous Pacific Island communities to promote breadfruit as a sustainable protein solution for food-insecure tropical regions. Recognizing its extraordinary yield efficiency compared to conventional protein crops. Grows in USDA zones 10 through 12. Tropical and subtropical climates only. Number 10. Winged beans. Sophocarpus tetragonalobus. And a 1975 report by the National Academy of Sciences of the United States described this plant as one of the most nutritionally promising crops on the planet. That report was published nearly 50 years ago. Western agriculture largely ignored it. Most people in North America have never seen a winged bean. The seeds contain 29 to 39 grams of protein per 100 grams dried, rivaling soybeans in protein content and amino acid completeness. The tuberous roots contain 20 grams of protein per 100 grams, more protein than potatoes by a factor of approximately 5. The leaves and flowers are edible and protein-rich. The young pods can be eaten whole. Every part of the plant. Edible. Protein-containing. That is why it was called a supermarket on a stalk by agricultural researchers in Papua New Guinea, where it has been a primary food source for centuries. A comprehensive nutritional analysis published in the Journal of Food Science confirmed winged bean protein's complete amino acid profile and high digestibility, noting that it compares favorably to soy protein, the gold standard in plant protein, across every measured parameter. Grows in hot, humid tropical and subtropical conditions. Full sun. Trellis required. USDA zones 9 through 12 as a perennial, grown as an annual in warmer temperate zones. 10 plant foods in. Every single one different from what you find on standard lists. Every one backed by published research and real historical data. If this video is giving you information you genuinely have not found anywhere else, hit like right now. One click. That tells YouTube this content deserves to reach more people who have been overpaying for protein their entire lives when these plants have been available the whole time. Hit like. Number 11. Pili nuts. Canarium ovatum. And these Philippine native nuts are what serious nutritionists are calling one of the most complete, most bioavailable, most overlooked protein and fat sources in the world. Pili nuts contain 10 grams of protein per ounce, more protein per ounce than almonds, cashews, or walnuts. The fat profile is exceptional, predominantly oleic acid, the same heart-healthy monounsaturated fat found in olive oil, combined with meaningful levels of omega-3 fatty acids. But here is what genuinely sets pili nuts apart. They contain the highest magnesium content of any nut documented in nutritional databases, over 300 milligrams per 100 grams. Magnesium is involved in over 300 enzymatic reactions in the human body, including protein synthesis, muscle function, and energy production. The majority of Americans are clinically deficient in magnesium, a protein source that simultaneously addresses the most widespread micronutrient deficiency in America. Indigenous Filipino communities have harvested pili nuts from wild Canarium ovatum trees for centuries, using the nuts as both food and the shells as a traditional fuel source. Modern cultivation is expanding as international nutritional interest grows. A study published in Food Chemistry documented pili nut protein's high digestibility and complete essential amino acid coverage, positioning it favorably against commonly consumed tree nuts as a protein source. The taste is buttery, rich, and mild, genuinely one of the most delicious nuts available, found through specialty retailers and online sources. Number 12. Tepary beans. Physalis acutifolius. And these small, dense legumes from the Sonoran Desert are the most drought-adapted, most protein-dense, most medicinally documented bean most Americans have never heard of. Tepary beans contain 23 grams of protein per 100 grams dried, more protein than black beans, kidney beans, or pinto beans. They have been cultivated by indigenous peoples of what is now Arizona and Mexico for at least 5,000 years, surviving in desert conditions that defeat every other common bean species. Here is the scientific data that is driving serious research interest. A team at the University of Arizona studying tepary beans documented that their unique lectin and protein structure demonstrates selective cytotoxicity against cancer cell lines, specifically colon and breast cancer cells, in laboratory conditions, while leaving healthy cells unaffected. That research is preliminary and does not constitute medical guidance, but the biological mechanism is being actively investigated as a potential basis for therapeutic development. Separately, tepary beans have a lower glycemic index than almost any other legume studied, making them particularly valuable for blood sugar management. Research from the University of Arizona found regular tepary bean consumption associated with improved insulin sensitivity in participants with metabolic syndrome. They adapt remarkably quickly to local growing conditions. Each generation of saved seeds becomes more attuned to your specific soil and climate. Full sun, very well drained, lean soil, minimal water. USDA zones 5 through 11. Number 13, chaya, Cnidoscolus aconitifolius, also called tree spinach. And this Mayan superfood is what nutritional scientists are describing as one of the most productive, most nutrient-dense, most underutilized food plants in the world. Chaya leaves contain 5 to 7 grams of protein per 100 grams fresh, significantly more than spinach, kale, or broccoli in equivalent fresh weight. But the complete nutritional picture is what makes chaya extraordinary. A study published in the journal Plant Foods for Human Nutrition found chaya superior to conventional leafy vegetables across nearly every measured nutrient, including iron, calcium, vitamin C, and beta-carotene, in addition to its protein content. Chaya was a primary food source for the Maya civilization for centuries. It sustained populations through drought, crop failure, and the disruptions of colonial contact, because a single established chaya shrub produces leaves continuously, year-round in warm climates, with essentially zero inputs. The Food and Agriculture Organization of the United Nations has identified chaya as a priority crop for food security programs in tropical regions, recognizing its extraordinary yield efficiency and nutritional density. One critical safety note: chaya leaves must be cooked before consumption. Raw leaves contain hydrocyanic glycosides that break down completely with 5 minutes of heat. Cooked chaya is completely safe and delicious, similar in flavor to spinach but richer and more substantial. Propagates easily from stem cuttings. USDA zones 9 through 12 as a perennial. Grown as an annual or container plant in cooler zones. Number 14, Moringa oleifera, the miracle tree. And while Moringa appears on other lists, the depth of scientific documentation behind it demands its inclusion on any honest protein plant ranking. Dried Moringa leaf powder contains 27 grams of protein per 100 grams, comparable to chicken breast by weight. Fresh Moringa leaves contain approximately 9 grams per 100 grams, more than eggs per calorie equivalent. The Food and Agriculture Organization of the United Nations rates Moringa among the most nutrient-dense plants ever systematically studied, containing all 9 essential amino acids, more iron than spinach, more calcium than milk, more potassium than bananas, and more vitamin C than oranges. That combination, complete protein plus exceptional micronutrient density, is essentially unique in the plant kingdom. A clinical study published in the Journal of Food Science and Technology documented Moringa leaf supplementation significantly improving protein and micronutrient status in malnourished children over a 60-day intervention period, with results comparable to conventional nutritional supplements at a fraction of the cost. Here is the agricultural data that explains its growing importance globally. Moringa trees begin producing harvestable leaves within 8 months of planting from seed. They tolerate drought, poor soil, and heat that defeats most food crops. A single mature tree produces leaves continuously for decades. USDA zones 9 through 11 as a perennial. Grown as an annual or in containers in cooler zones. And number 15, tree collards, the perennial brassica that produces protein-rich leaves continuously for decades and represents the most compelling argument for long-term thinking in food production that I have ever encountered. Tree collards contain 4 grams of protein per 100 grams fresh, combined with exceptional vitamin C, vitamin K, calcium, and fiber. That protein content sounds modest until you apply the time dimension. A single tree collard plant, established once from a cutting, in a mild climate produces harvestable leaves every week for 20 to 40 years. The cumulative protein yield from one plant over 2 decades absolutely dwarfs any annual vegetable crop, at zero ongoing cost after establishment. They were brought to California by Portuguese settlers from the Azores, where farmers had grown them for generations as a reliable, perennial food source. In the 1970s, ecological gardener Alan Chadwick helped revive them in the United States. Seed-saving communities have maintained them ever since, passing cuttings from garden to garden because they rarely set viable seed. There are documented tree collard plants in California that are over 40 years old, still producing, still being harvested, still feeding families from a single cutting planted 4 decades ago. A 2018 analysis of perennial food crops published in the journal Sustainability identified tree collards as among the most productive perennial protein and micronutrient crops available for temperate and warm temperate growing zones, specifically recommending them for food security and reduced input agricultural systems. USDA zones 8 through 11. Part shade to full sun. Propagate from stem cuttings. Having this list is only useful if you know how to apply it. Here's the practical framework. Step 1. Start with 2 or 3 plants that fit your existing cooking habits. If you already cook soups and stews, fava beans, lupin beans, and tepary beans slot in immediately. If you already make smoothies, spirulina and moringa powder add protein, with minimal flavor impact. If you grow a garden, tree collards and chaya are long-term perennial investments that pay back for decades. Do not try to change everything at once. Start with 2 plants. Cook with them consistently for 1 month. Add 2 more. Step 2. Understand that protein combining across the day is what matters, not protein completeness per meal. Your body maintains an amino acid pool. Amaranth at breakfast, plus teff at lunch, plus fava beans at dinner, creates a complete amino acid profile across the day, even if no single meal is technically complete on its own. Stop evaluating individual foods in isolation. Evaluate your daily dietary pattern as a whole. Step 3. Track your protein for 2 weeks when you start. Most people transitioning toward plant protein are surprised to find they are meeting or exceeding their protein targets far more easily than expected once they know which plants to reach for. 2 weeks of tracking builds the dietary intuition you need to stop tracking forever. The target: roughly 0.7 to 1 gram of protein per pound of body weight per day for active adults. That is achievable from the plants on today's list. The research confirms it. The populations that have been doing it for thousands of years confirm it. That practical framework right there. Start with 2 plants, understand daily amino acid pooling, track for 2 weeks, is the actionable bridge between this list and actually changing how you eat. Most protein plant videos give you a list and leave you without a plan. This channel never does. If you found genuine value here, subscribe, free, and share this with one person in your life who is spending too much money on protein supplements when these plants exist. They need to see this. 3 questions, and I genuinely want these answers. Question 1. Which of these 15 plant foods are you trying first? Just one. Tell me the plant and how you plan to use it. Cooking, growing, supplementing. I want specifics. Question 2. Which entry on today's list shocked you the most? The one that completely defied your expectations about what plant protein looks like and what it can do. Question 3. And this is the one I really want you to sit with. If you calculated what you spend annually on meat and protein supplements, and then compared that to what you could achieve with even 5 plants from today's list, what would that number look like? Drop everything in the comments. I read every one. This is a real community, and your answers genuinely shape what I cover next. Here is what I want you to carry out of this video. The protein conversation has been incomplete, not accidentally, deliberately, because complete information leads to informed choices, and informed choices do not always benefit trillion-dollar industries. These 15 plants have been sustaining human populations, building civilizations, fueling warriors, feeding families through hardship, for thousands of years before the first protein shake was ever invented. They are real. The science behind them is real. And the opportunity to build a diet that is more affordable, more nutritious, and more sustainable than what most people are eating right now, that is real too. Pick one plant from today's list. Just one. Find it, cook with it, grow it if you can, and come back and tell me what happened. Because that story, your relationship with food changing because of one plant you had never considered before, that is exactly why I make these videos. If this video changed how you think about protein, share it. Send it to one person who is spending money every month on protein supplements when these plants have been available their entire lives. It costs you nothing. It might genuinely change how they eat. Like the video. Subscribe to this channel, and I will see you in the next one, where we go just as deep on the food systems and plant knowledge that most people never get access to.